okay? 0.9, it's less than the 1 that is the water, so it floats, but just lower in the water than this. Now, as an extreme example, this is always cool, the styrofoam here. Let me drop the styrofoam in there, and then you really can see, maybe if I...
Okay, the minerals here are quite large. Potassium feldspar here. This colorless stuff all in here is quartz. These are very large minerals here. And this tells me this cooled deep below the surface. Took a very long time to cool. Here I have the mineral calcite, and I have some hydrochloric acid that I'm going to drop on there, and hopefully we can see this fizz. Here we go. Oh, you see that quite good.
That in. It's a little bit blurry. And the second one, look, can you see the reflection? Okay, good. Mr. Miller, can you see? Oh, wait a second. Now I'm like that. Oh, yeah, right there. Pretty much, yeah, right there. Okay, see how it's all in line? The pin itself is right here, but the image of the pin in the glass is right there. You see that? Pretty cool, because it's refracted.
Is salt water from the Atlantic Ocean, and it's traveled all the way up here. I'm going to fill this pot. I'm going to turn the stove on. And hopefully you can see that better right there. Now if I take a knife, let me scrape that away. You can see, hopefully you can see that. I'm not sure if the camera can focus on this. That is halite.
This is volcanic glass, or obsidian, and you can really see how it breaks very circular. It's called conchoidal. Look at that. And everyone likes this. It's really shiny. This is volcanic glass. This is from lava that flows on the surface of Earth that cools very quickly.
Between 73 and 78. Yes, 70 is. So now I'm going to go like that. Is 70 between 58 and 60? No. Is it between 58 and 73? Yes, it is. So then I go like this.
And now, this is the warm part of my experiment. The baking soda that I have in there is about 68 degrees. It's room temperature. And the vinegar I warmed up in the microwave is right at 158 degrees. So I'm going to add them together, and we're going to see how this reaction compares. In 3, 2, 1.
Hold it down, grab it firmly, and then press, eyes closed. And I really feel that dig in. You can even hear it dig in. This is clearly scratches the glass. And again, you feel it like dig into the glass, drag on the glass. So to show you actual fingernail, I'm going to do a close-up, and maybe I'll do it. Does that look okay, Kate?
Yes.
Okay. So you go like this with your fingernail down to the ground. Again, down to the ground. What you don't do is don't do that. That's no good. Okay, so what we show, I like drawing a person in there to think I'm that person. It helps. We call this due north, due east, due west, due south means directly. So what you have, this is the sun's path. This is where it rises, okay, and the sun goes up here. This is solar noon. It's 72 degrees up. This angle that it would make for this person there, 72 degrees above the horizon. And then it goes here. It's probably very heavy with sediment. And then the finer stuff does get carried out. You see it getting carried out. Love that picture. Okay, now this is labeled actually, and I have a few things. This is called the mouth of the stream. It's where the stream empties out into a larger body of water, a lake, an ocean. Okay. Another half-life goes by, so half of the carbon-14, the blue you have here, will become nitrogen-14. That will stay nitrogen-14 forever. It's stable, so it will look like that. And now we're talking another 5,700 years. So this is and I do want to point out, glaciers, when they move, they're not just ice. Along the way, they pick up a lot of sediment, all different sizes, sand, silt, clay, cobbled, boulders the size of a car, the size of this room. And this picture shows it quite well.